Okay, so the law of cosines is for when the law of sines just can't work. And there's two cases when this happens. Basically, we could summarize them by the triangle congruence postulates that we used to talk about. If you had side, 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 or side, angle, side, there's no way that the law of sines could work. For example, if we knew this angle A here, and this side B, which would be across from angle B, and side C here, which would be across from side C. So if we knew this angle and these two sides, then what we could, if we set up the law of sines, it would be sine A over an unknown, because we don't know that one, and then we don't know these two angles either. So there's no way that we could set up the sine ratios to equal that one. So let me erase those real quick. And what I'd like to propose to you is a way that we can do it. So likewise with side, 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 if we knew that we were dealing with three sides, we don't know any of the angles, so we can't set up sine A over A or A over sine A. So what we have to do is we have to use the law of cosines. Now the law of cosines works because it gives us a ratio. And the proof of this one is a little bit longer. So what I'm going to do is I'm going to give you both of the forms, okay? So the triangle is still set up as A, B, C, and then little c, little b, and little a. But the letters really don't matter. It's inconsequential because really when you look at the law of cosines, you have an angle, and then basically you're dealing with the two sides across from it. So there are two forms. There's one where you solve for the side length. This is the side length form. A squared is equal to b squared plus c squared minus 2bc times the cosine of a. Now these are all multiplied right here. It's 2 times b times c times the cosine of a, but we write them next to each other because hashtag algebra. Now notice that this a squared here would be the side length, and the only other time you see a is in the cosine ratio. So the side length is equal to the other two sides squared minus 2 times the two sides times the cosine of angle A. Okay, so that's one form of the law of cosines. This is used to find sides. Now, the other form of the law of cosines is basically just a rewritten version of it. So it's if we were solving for the angles instead. So all they do is they solve it using algebra. So here's the other version. Cosine of A is equal to b squared plus c squared minus a squared all over 2bc. Again, I want you to make note that a is here and it's the one that's subtracted. Otherwise, it's all b and c. Okay, so if you can remember these two forms of the law of cosines, you'll be good. This one is the one that's best used to find angles. Basically, all we're going to do is plug and chug on this. So I've got a couple of examples that I want to work for you. Let's look at them. Solve the whole triangle. Okay, to solve this one, this is a side angle side problem. We have a side, an angle, and a side. Again, there's no way to use the law of sines on this because we don't know side A and we don't know angle C or angle B. So what we're going to do is we're going to solve for side A. If we solve for side A, then it's real easy. We will use the primary form, which is a squared equals b squared plus c squared minus 2bc cosine A. So all we have to do is plug the numbers into this formula and we'll get it. So a squared is then equal to this would be little b over here, and this is little c. So b squared is 15.1 squared plus 18.5 squared minus 2 times 15.1 times 18.5 times the cosine of angle A, the cosine of 94.1 degrees. That's what I'm going to type into my calculator. Hopefully I can remember all this. Just a second here. Let me see if I can pull my calculator up here in split screen mode. Let me even make it a little wider so I can type all that in there. Okay, so we got 15.1 squared plus 18.5 squared minus 2 times 15.1 times 18.5 times the cosine of 94.1. It looks like it took everything correctly. Now, the problem here is that what I've solved for is actually a squared. So a squared is equal to 408.2. So what I need to do in that case is square root both sides to find out the exact form of a. So let me take the square root of all that. And I get 20.2. So this side length here is 20.2. Now, I'm not going to finish solving the rest of this, but if I were to finish solving the rest of it, I can now just use the law of sines. Since I know angle A is 94.1 and side A is 20.2, I could set up the sine of 94.1 over 20.2 is equal to sine of, let's say, C over 18.5. And I'd cross multiply, take the inverse sine, and I'd have it. So that's how I could finish solving for angle C. Then I really just need to subtract from 180 to find angle B. Okay, example number 2. This one is a side-side-side problem. So with the side-side-side problem, what I'm going to do is I'm going to set up and use the other version, because now I need to solve for an angle. So let's say angle A again. I'm going to solve for this one here. To solve for angle A, I would use the cosine of A formula. Cosine of A is equal to B squared plus C squared minus A squared, all divided by 2BC. Then all I'm going to do is plug it in and take the inverse cosine. So this would be little b over here, this would be little c over here, and this would be little a over here. So let's go ahead and plug them in. B squared would be 15.4 squared plus c squared, which is 13.9 squared, minus a squared, which is 16 squared, divided by 2 times 15.4 times 13.9. Okay, so now that's what I type into my calculator. That's cosine of A. Okay. Actually, let me drag it up and split screen it again. Okay. So this one is going to be 15.4 squared plus 13.9 squared minus 16 squared, all divided by 2 times 15.4 times 13.9. Okay, so that gives me 0.4072. Now, if you wanted to, you could look up on the chart, the trig tables, what that is. So cosine of A is equal to 0.4072. You can look up what that is equal to, but we can also take the inverse cosine of both sides. Cosine -1 of that, and give me 65.9 degrees, so 66 degrees roughly. So we'll say angle A, measure of angle A, is equal to 66 degrees. So that gives me this one here. Okay, so sweet. From that point, now I've got the angle. I could, again, set up the law of sines. I could do sine of 66 over 16 is equal to, and pick any of the other two angles to plug into. So let's say sine B over little b. And that would give me the ability to solve for, well, actually b is 15.4. That would give me the ability to solve for angle B, and then I could subtract from 180 to find the other two.